Alright, so in this video, I'm really going to focus on why factor by grouping works and how it works, so that you can see it sort of in a generalized way as well as in a specific way. So going back to the prior lesson, or one of the prior lessons, you might have hopefully seen the pattern where if you have s times x plus h times r times x plus k, and you multiply that out, you would always get s times r, all times x squared. And I'm just going to add parentheses here, you don't need to, but just for emphasis to show that s and r will always equal the a value. And then in the last term, you would get h times k for your c value. And hopefully you saw for your b value, it was this combination of s times k plus r times h. Hopefully you saw that. If you didn't, go back and look at that prior problem. Make sure you understand this general idea, because this is really important in getting us to where we need to go. So the question now is, how do I go backwards? So I'm gonna march it backwards from a generalized perspective, and then once I do that, I'll make the specific step on the problem we have here, which is 12x squared plus 16x plus 5. So to march backwards, your first step is to take the product of my a value, which is sr, and my c value, which is hk. So the product of sr and hk is s times r times h times k. It's the product of all of those. And so that is my a times c. We'll often call that my a times c value. And I want to find a number that multiplies to my a times c value that adds to my b value. And to remind me, my b value in this specific case is s times k plus r times h. That looks a little weird, right, with all these letters. What do I mean by that? I'm looking for things that multiply to s times r times h times k that add to b, which is s times k plus r times h. Well, it turns out two things that multiply to ac that add to b in this case is exactly s times k and r times h, right? Because when I multiply those together, I get s times r times h times k. And when I add them together, I get s times k plus r times h. So it's pretty weird and kind of obvious in this general case. Let me show you how it works in the specific case, and that might help. So again, I'm looking for things that multiply to my a times c, which is 60, that also add to my b value, which is 16. And so I'd go through the factors of 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 no, 8 no, 9 no, back to 10. So those are all my factors. And now I'm looking, do these add to 16? No, no, no. 19 getting closer, 17 getting closer, 16. Yes, that's my number. So 12, or 6 and 10. So what I do now, so I've identified the two numbers that multiply to AC and add to B, just like I have SK and RH here. So now let me go back to the general step and tell you what I do next. So what I'm going to do is I'm going to take my BX value and break it into two different values, the ones that I found here. So follow along here. So I'm going to do SR times x squared, that hasn't changed, plus SK times x, which was my first number that I found, plus RH times x, which was the second number I found. So I've taken that middle term and broken it, the b value, and broken it into just the two numbers that I found that added to b and also multiplied to ac. And then I keep my hk. Again, looks a little strange here in the general case to some of you, but let's use it on the specific case, and I think that will help. So now I'm going to break my 16x up into 6x and 10x, both positive. So I get 12x squared plus 6x plus 10x plus 5. And the order that I write that doesn't matter. And in fact, I'm going to write it that order this time, and then I'm going to do this exact same problem and write it in a different order and show you why in the general case and the specific case you will get the same answer. So going back to the general case now, I'm going to group the first two terms, and I'm going to group the last two terms. Now keep in mind I keep a plus in between there, but I still have to keep track of the fact that this is positive. If I had a minus there, I would still keep the minus with the RHX, but I'd have to put a plus in between so that I don't lose track of the fact that I'm adding these two things. So in that, the way I look at this is I group these two, and I'll make sure I remember that's plus, and group those two. So specific and then general. Stay with me, go back and rewind if you need to figure out what I'm doing here. So what I'm going to do is look for the greatest common factor of, maybe I'll call it the green group. And then later I'll look for the greatest common factor of the purple group. So the greatest common factor of the green group is s times x. Because there's an s and there's at least one x there. There's an s and at least one x there. So I'm left with r times x plus k when I factor the s x out. Likewise, when I factor the purple group, the only thing that the two terms have in common is h. So therefore I'm left with rx plus k. And you'll notice that I have the same thing in both here. So I can actually factor it out of both terms. And when I do that, I get rx plus k factored out, and what I'm left with is sx in the first term and h in the second term. And notice that this is exactly the same as what we started with. So that means I can factor completely in this way because I've just started with something that I knew I expanded. I took it and I refactored it. So again, what does this look like in the specific case? So the greatest common factor between 12x squared and 6x is 6x. When I factor that out, I should be left with 2x plus 1. Likewise, the greatest common factor of 10x and 5 is 5, and when I factor that out, I get 2x plus 1. And now I can factor out a 2x plus 1 from both, leaving me with 6x in the first term plus 5 in the second term. So lo and behold, I have factored 12x squared plus 16x plus 5 into 2x plus 1 times 6x plus 5. How do I know it worked? Well, let's redistribute to make sure. 12x squared plus 10x plus 6x plus 5. Notice how similar that looks to what we had up here. The grouping's a little different, but it is in fact the same. And now, if you're stuck here, this would be a good time to sort of pause, talk to your group about what you saw, rewind steps, and write down some questions about, in certain steps, where did you get stuck? For those that sort of want to see this one more time, maybe in a different way, I'm going to proceed. So again, looking at the general step, going back, what I did before was I ended up grouping the skx term with the srx squared term. So I'm going to do that differently this time. So again, writing the general form, I knew that s times r x squared is, because s times r is my a value, plus s times k plus r times h times x gives me my b value, plus h times k gives me my c value. And now, again, as you recall, I'm going to look for numbers that multiply to s times r times h times k, which is a times c, that also add to my b value, which is s times k plus r times h. Obviously, the two things that add to sk plus rh that also multiply to sk rh is sk and rh. So looking at our specific case again, what was the original problem? I believe it was 12x squared plus 16x plus 5. I'm not doing anything differently, right? I'm looking for numbers that that multiply to 60, which is a times c, and add to 16. And again, it's the same numbers, 6 and 10. But what I'm going to do differently here is the way I group them. So before I had s times r x squared plus, and I took the sk and brought it over here. Right? I basically took the first piece with the x and brought it over. I'm going to take the second piece just to show you that it works either way. So I'm going to bring the rh times x and pull it over there, and then I'm going to put the skx and put it over here with the hk. Show you that my factor by grouping should give me no different result. Likewise, what I did up here was I put the 6x first and then the 10x, so I'm going to reverse that. So 12x squared plus 10x plus 6x plus 5. So I just flip-flop the 10x and the 6x. And now I'm going to group. First two, second two, and factor. Greatest common factor in the green, in the general case, is r times x. And I'm left with sx plus h. And in the second group, the greatest common factor is k, and I'm left with sx plus h. And so factoring out sx plus h, I'm left, and the other is rx in the first term, plus k in the second term. And again, that is the general form that I started with and that I found right above here, right? In green, you'll notice it's exactly the same. The order is just reversed. But in multiplication, you can reverse the order and it still equals the same thing. So again, let's do it on the specific case. The greatest common factor between 10x or 12x squared and 10x is 2x, leaving me 6x plus 5. The greatest common factor in 6x plus 5 is 1, leaving me 6x plus 5. And so now you know 6x plus 5 is in both, so when I factor that out, I'm left with 6x plus 5 times 2x in the first term and 1 in the second term. So 6x plus 5 times 2x plus 1, I believe, is exactly what we found in the first one, right? 2x plus 1, 6x plus 5. Again, the order is reversed, but it is exactly the same. So this is why factor by grouping works, is because in this general form, where s times r gives me my a value, sk plus rh gives me my b value, and h times k gives me my c value, I can take advantage of this ability to group them to then eventually find the factor. So I hope that helps. If it doesn't, please give me some suggestions. I'm happy to redo this video in any way to help future generations of algebra students. Thanks so much.